Hello, DevOpsDays Kraków. Thank you for having me as your first presenter. So today I will present you security as code, a DevSecOps approach. A few words about me first. So I spent 10 years in a fintech company when I was in charge of deploying software practices and culture. So extreme programming, test-driven development, agile, DevOps. And now, as head of the GitHub security lab, I'm basically doing the same thing, but with secure code in open source. So I'm French, but I live in California. So here it's a few minutes past midnight. So I won't stay long after the talk to answer the questions on Discord, but I will catch up when I wake up. Sorry about that. A few words about what I'm doing now. So I'm the head of the GitHub Security Lab, and our mission is to help secure open source code. So what we do is that we audit code, open source code. We report security vulnerabilities to the maintainers. We help them fix them. We use also this research work to publish educational articles or trainings or workshops. And we use also this research to write automated checks so that this problem do not happen again in open source. And we also provide high-quality security advisories to notify the entire ecosystem when there are security vulnerabilities out there. We do all of this for free for open source. It's our contribution to open source. And more importantly, what we try to do is to build a community of people willing to contribute to this effort for the open source projects. So today, my talk is about security as code, and a DevSecOps approach, but let me start with a short science fiction story. I think you have all seen the landing of the Perseverance rover on Mars a few weeks ago. And GitHub CEO Nat tweeted that our CodeQL tool was used in the drone flight software. Actually, CodeQL was already used by the NASA engineers 9 years ago. 9 years ago, it was another rover who was flying and about to land on Mars. It was the Curiosity Rover. And the NASA engineers found a bug in that rover while it was already in flight. The pseudocode that you see here, it's a C code. And in C, even if the parameter of a function is declared as an array of size 12, you can pass an array that is shorter. Well, you can pass an array of any size. And if you pass an array that is shorter, then the behavior here will be unpredictable. So they found the bug, they patched the bug mid-flight, they deployed it remotely to Curiosity. But we thought, okay, but are there other occurrences of this bug out there? So what they did is that they checked their code with CodeQL. The query that you see here on the right, it searches your code for all cases where the argument which is passed to the call of the function is an array of size shorter than the parameter that is declared for this function. And by just running this query on their code, they found not less than 30 variants of the same patterns. Some of them were critical and would have prevented the parachute to open and would have caused the rover to crash on Mars. And here I'm talking about a literal crash of the rover and not a software crash. So they fixed all of them mid-flight, they deployed them remotely, and the Curiosity rover was able to land safely on Mars. How cool is that, right? That's super cool story. But what is cooler is if all open source developers could use the same approach to secure their code. And this is what I'm going to talk about today. So first, I will talk about what is specific to security when it comes to shift left, because all of you know about DevOps already, but what is specific to security? And I will start with addressing some misconception about shifting left. So first, shifting left doesn't stop at the coding phase, right? There are software activities that are at the left of the coding phase, like requirements, design, architecture. And when you think about shifting security left, you should shift up to those activities. You shouldn't stop at coding. Well, of course, today I will stop at coding because I have only 30 minutes. So I will basically do exactly what I just told you not to do. I will stop at the coding phase. The second misconception is that shifting left, it's not just about automating and running earlier in the life cycle, in the development life cycle. I've seen that a lot of times, and I've seen it failing a lot of times, right? What I've seen is that you tell your testers or your ops or your security team to just automate what they're doing and run it earlier into the process. At the beginning, it will give you a false impression of success because, well, you're automating work, you're running it more often. So it's good. It gives you an impression of success, but after a while, it stalls and it fails. It fails because it doesn't change deeply the practices of your development team. Okay, so what do we need to change the practices of the development team? What motivates developers? In his book, Drive, Daniel Pink tells us that it's a combination of autonomy, mastery, and purpose. Autonomy is about being free to try stuff and to do stuff. It's about being in control of what you're doing. Mastery is about being good at what you're doing. And purpose is about knowing why you do what you're doing. And so if you take my example, what I was talking about, right? It's just asking the testers or the ops or the security team to run their tool and then to run them earlier and then tell the developers to fix something, then it's not that, right? You have another team running their tool and just generating a deluge of Jira issues for you to fix. Well, you're not autonomous, you're not in control. If you do that, also the expertise stays in that team and the developers don't learn anything in the process. So same thing, no mastery. The developers do not improve and do not become good at what they're doing. And then purpose, well, if you are just fixing a bug because the expert said so in the issue, same thing, you don't even know why you are doing the thing. So with that approach of just automating and running earlier, you don't give your development team autonomy, mastery, and purpose. And this is why the practices don't stick. So let's now see what are the specificities of security when it comes to shifting left. First, let's see what is common. Well, what is common is basically the divide between the two communities, right? It happened with testers. Testers were told that they shouldn't trust developers. And then it happened with ops. Ops were measured on the stability of the system, where developers were measured on the number of new features that they were adding. The same happens for security, right? Developers are asked to develop features faster. They are asked to make things easier for the end user. They are asked to optimize the product, and this can happen sometimes to be incompatible with some security requirements. So really, you have this common problem of divide between the two communities. What is specific? First off, I think the criticality, the urgency of the security bugs, right? A security bug can really jeopardize the entire integrity of your system. It can leak personal data from you, from your customers, which is even worse. The second point is that security researchers are quite a rare population compared to developers, right? So mechanically, they are less available to help. And this is in particular in open source, there is a perception that the security researchers have bad intentions. They are not really here to help the open source developers. They are here for the money, for the bug bounties, or they are here for their personal reputation, or even just for the fun of attacking software. There is this false perception in the community. So at the end of the day, with these specificities, what happens is that the divide between these two communities is really at another level. And how do we solve that? So to solve that, let's see what we learned from DevOps, what worked with DevOps, and let's try to apply it to security. So the first thing that we did to really apply a DevOps culture is to bring together the team by aligning the goals, right? So for example, we did it with developers and testers. We said, okay, QA, your goal is not anymore to find bugs, your goal is to prevent the bugs. Okay, and then we did it for devs and ops. We said, okay, ops, your goal is not anymore the stability of the system, but it's reduce the downtime of the production. And basically, we found goals that could be common for the two communities, for dev and testers, for dev and ops. So in an organization, you should basically do the same for dev and security team. You should align their goals, make them work on the exact same goal. In open source, an example of what we're doing in open source at the security lab, we have a bounty program, okay? But instead of paying the hunters for finding security problems, we pay the hunters for developing automated checks that prevent these problems. Okay, so this is basically this paradigm shift, right? You need to align the goals of the two communities. So that was about the purpose. Now, how do we give developers autonomy and mastery when it comes to security? Well, what did we do for DevOps? Basically, we gave them developer tools that they could autonomously run, learn, master, right? What we did also is that, okay, instead of putting the ops in really accountable for all the production problems and the deployment problems, what we did is that we said, no, the ops will be expert who will support the developers, but at the end of the day, the guy who commits the code is the one accountable for the bug. So autonomy, right, and mastery thanks to the tools. And in particular, what I observed is that one of the successful levels for DevOps adoption has been infrastructure as code. With infrastructure as code, the developers could, well, they were excited because it was code. They could read it, they could understand it, they could learn it, they could contribute to it. At the end, ops were speaking their language. It was beautiful. And the same is true with the adoption of testing by developers, right? The unit test frameworks or the functional test frameworks like Fitness, Selenium, Cucumber were a great help to foster the adoption of automated testing by the developers. So could we do that for security? Well, yes, we can do that with security with security as code. And this is what I'm about to show you. So you remember in the NASA example that I showed you, I talked to you about how CodeQL was able to find a vulnerable code pattern. So how does that work? CodeQL is a tool. It's a tool that is free for open source. It's a tool that extracts your code into a special database. Well, it will extract the abstract syntax tree. It will extract the semantic information. It will extract even the control flow graph. And then once all your code is in that DB, then you can query that DB, right? But you don't query it just with a SQL query. You will query it with an optimized object-oriented language. Okay, time for a quick demo so that you can see what it looks like. So here, I'm in my VS Code editor, and I installed the CodeQL for Visual Studio Code extension. Once you install this extension, it's pretty straightforward. You have everything ready to go. And in particular, what I did is that I cloned the CodeQL starter workspace repository that is available on GitHub. And I imported a CodeQL database and a CodeQL database that contains a bug. What I will do is that I will show you the bug to start with. So of course, this bug has been fixed since. I wouldn't show you a security bug that still exists. So I'm in min.io, and min.io is an Amazon S3 compatible object store. This function, validate admin signature, as the name says, this function checks that the request that is sent by an admin. Okay, so what we do is that here we check that the request is authenticated with an admin private key. We get the error code, and we check if there is an error, and if there is an error, then we log it. Good, but we don't return the error. Instead, we continue treating the request. And that's not good, of course. We should have returned the error here. So this is a critical bug. This is a critical bug. This bug was allowing non-admin to launch admin requests to min.io. And the bug was fixed by adding here, line 143, a return of this error code. So let's see if we can code this security pattern with CodeQL. So what we are looking at is an error code, the check of an error code where we miss a return statement, okay? So let's begin with that. I've prepared an example for you of a CodeQL query. So first off, we import the Go libraries. So as I said, it's a language, so you benefit from the existence of reusable libraries per language. And then all the queries are under the form from where select. It's really like a SQL query. So what we are looking at here is we are looking for the if statement where in the then branch of this if statement, there is no statement that is of type return statement. And then we select the result. Let's run this query just to see what it gives us. Okay, so on the right here, I get all the results of this query. If I click on one of them, it will bring me directly to the code. So here, when I look at the code, I can see that indeed, this is an if statement and there is no return statement in it. If I look at another one, okay, you get the point. This is an if statement and there is no return statement in it. Okay. So for our case, we are not interested in all if statements, right? We are interested in the error checks. We want to find the error checks where there is no return statement in the then branch. So let's have a look at that. We basically want to find cases where in the if statement, we are checking something against error none. Okay. To model the query, what we will do is that we need to identify what tables we need to query. And we will do that with the AST viewer. So here you have a tool that allows you to see all the abstract syntax tree of the file that you're in. So let's do that. It's computing the AST. And I have it. So for example, if I want to check my function, I see it here. So I got my function declaration here. Okay, inside that function declaration, let's go to the block statement, which corresponds to the body of my function. Let's open it. Then let's go line 139. Okay, so this is my if statement. Inside my if statement, I get a netexp, which is a not equal expression. And inside that not equal expression, I have two ident for identifiers, one being a variable name, one being the constant name error node that I'm looking for. Okay, so if statement, not equal expression, identifier, I've got all the object types that I need to query. So let's go back to my query. Oops, sorry, I have to move that. So I need to query the if statement, the not equal expression, and the identifier. Then what I do is that I will basically define my joins. I will say that my if statement, there is a condition. Wait, yeah, the condition in my if statement is the not equal expression. And I will say that one operand of my not equal expression is my identifier. And I will filter, I will say that my identifier is named unknown. Okay, let's run that query. Okay, I've got 5 results. If I have a look at the first one, that's good. I have an if statement checking for an error against error node, and the then branch does not return. Let's see the second one. Okay, the second one is my bug. It's the bug that I'm looking for, so that's good. I found my bug. Okay, let's have a look at the query. So you see, it really looks like a SQL. I'm defining my tables here. I'm defining my joins here between all these tables. I'm defining my filters here. My filters are, okay, the identifier should be named unknown, and there is no return statement in my then branch. And then my query runs. But with the CodeQL language, I got a way to be much more expressive than just a SQL query. What I can do is that I will get rid of that. I will get rid of all that. And I just can say my if statement has a condition. This condition is a not equal expression. So I can cast it into not equal expression. And this not equal expression has an operand that is an identifier. So I can cast it into an identifier whose name is unknown. And when I run that query, then I get exactly the same results, including the bug that I'm looking for. So this is a way to really express your vulnerable pattern as code in a much more readable way. Now let's imagine that in my case, I'm not checking if my error code is different from unknown, but I'm checking if my error code is unknown. And then I am handling the error case into else bunch, right? And it's in this else bunch that I should return my error. How do I do that? I will create a class that I will name Powercheck instead of using directly the if statement. So my class extend if statement, I will define here the characteristic predicate of that class, and I will just copy this bit. I will say that my object here, the condition is not equal expression whose operand is an identifier named unknown. But I will not use the not equal expression. I will use the A quality text expression, right? Because I want to handle both cases. And I will create a function that I will name get error handling branch. And I will say if my condition is a not equal expression, then the result of this function is my then branch. Otherwise, the result of this function is my else branch. Okay. And here, instead of querying the if statement, I will query the error checks where the error handling branch of that error check does not contain a return statement. Okay, let's run that query. Okay, so when I run that query, first thing, you have more results because of course, you get these new cases when I'm checking if my error code is equal to error none, and in addition to the cases before, and here the else branch, well, the else branch doesn't even exist, so of course it doesn't return. And let's check that we still have our bug. Yes, we still have our bug. Okay. And let's go back to my query. So if you look at that query, you will see that really here, you have something that you can just read in plain English. I'm looking for all error checks where the error handling branch does not contain a return statement. And that's the way that you can really use security as code to define a security pattern that can be really easily readable, easily understandable by the developers. But you have seen also that, okay, I found my bug, but I also found a lot of false positives, things that I'm not interested in. What is really interesting for me is really, so where is it? It's really this bug where my error code should really stop the process because it's a really important error code. For example, here, my problem is that it comes from this function call is request authenticated, and this is the case that I need to check. I'm not interested in the other one. So how can I do that? Well, I check that one operand of my equality check is error none. So I need to check that the other operand is coming from a call to is request authenticated. Okay. But this function call can be in another file, right? So how can I do that? How can I track the return of that function from this other file? So I will show you the final query. So this is the final query. In CodeQL, you have a feature, a library which is called Dataflow, which allows you to track data flowing from one point in your code base to another. And it can follow the flows through different functions, through different files, okay? The only thing you have to do is to copy this boilerplate call and to define your origin point, the source, and to define your destination point, the sink. So here, for example, we define that the source is the result of a call to is request authenticated. And the sink is an operand to an equality test. And once you have done that, you have said, okay, so I've created my configuration, my data flow configuration, and my data flow configuration will really track data flowing from all calls to is request authenticated to all operand of an equality test. And then once you have done that, you get this, you can use this function hasFlow. This function hasFlow will return true whenever a flow is found from an eligible source to an eligible sink. So if I go to this function and I click on quick evaluation, let's see what we get. So these data flow queries take a bit more time, of course. So let's have a look at this, the first example that we see. And let me close this one. So here you can see that this one is indeed an operand to an equality test. So it's an eligible sink. But where does that come from? It comes from a call to check request authentication type. Okay, and here I'm in the file aclhandlers.go. But that function calls this other function in another file. And that function calls our function, is request authenticated. And you see it was in another file, right? So I'm really able, thanks to this data flow libraries, I'm really able to track data flowing from one file to another. Okay, so now what I'm doing is that I'm in my final query, I use this new capability to declare if my error check is actually checking an authentication result. And I use that in my final query. My final query becomes then, give me all the error checks where I'm checking an authentication result and my error on the branch does not contain a return statement. And if I run that query, then I got only one result. And that result is my bug. Okay. Okay, let's go back to our slides. And so let's see if we check all our boxes, okay? So with security as code, what I wanted first to have something automated. So yes, it's a query that is executable, that can work on your code. There is a CLI, it can run in your CI/CD. So cool. Is it a developer tool? Yes, it's a developer tool, right? It doesn't give you a report for security teams. It doesn't give you a report for managers. It's for developers. It lives in your IDE. If you're using GitHub, then it's fully integrated with your pull requests, as you can see in the screenshot on the left. And as you have seen in the demo, when you just click on the result, it brings you directly to your code for immediate action. Does it allow to share knowledge? So yes, the security researchers can express their knowledge as code in the query, right? And really the developer can read it, can learn by example by launching it on their own code. They can really understand and they can contribute to it, right? It's code. They can learn it and they can contribute to it. It becomes basically a way to communicate between developers and security researchers. And there is a bonus. The bonus is that the queries that you have seen are open source. This means that you benefit from the collective intelligence of the community. You benefit from a growing number of reusable libraries. You benefit from continuous improvement of the false positive that you might find. There are other tools, right, that are following the same principles. I'm thinking about SemGrep or Coccinelle. If you compare them to CodeQL, they are less powerful because they don't have, for example, the data flow feature that I was mentioning, and that feature is super important for security. But on the other hand, they are simpler, and so the learning curve is shorter. So thank you very much for listening to me. I wanted to show one approach, security as code, one approach of DevSecOps. So if you want to know more about that approach, please reach out to me or to the security lab. And of course, this is one approach. So I'd love to hear out your other ideas. So again, don't hesitate to reach out to me or to the security lab. Thank you very much. And thank you a lot, DevOpsDays Kraków.